Welcome to another episode of Zeroing In. I am Shreya Mishra, and hosting this episode with me today is Anoop, who is currently pursuing his bachelor's degree in avionics from the Indian Institute of Space Science and Technology, Trivandrum. Today, we are in conversation with a researcher who specializes in the field of instrumentation, analog signal processing, and sensor technology development. He completed his undergraduate from the College of Engineering, Trivandrum, and went on to take up his PhD as well as postdoctoral work at the Indian Institute of Technology, Madras, following which he joined IIT Kharagpur as assistant professor before taking up his current post at the Indian Institute of Space Science and Technology, Trivandrum. He has worked elaborately in varied facets in his field of expertise, like sensor design, signal conditioning, analog-digital interfaces, and direct digitizer, to name a few broad directions. While these fields find relevance in the everyday lives of the whole community at large, a plethora of details often go amiss. In our conversation with him, we discuss the elaborate details and processes that go into designing sensors and circuits that are employed in a wide spectrum of applications, ranging from medical sciences to the space industry. We also talked about his experiences, ideas, and his unique methodology that he applies both to his teachings and his research work. A very warm welcome to Dr. Anoop C.S. So, once again, thank you, sir, for joining us today.
Thank you. Thanks for welcoming me.
Of course, sir. So, we'd like to begin the discussion by a very fundamental question, that is, what are your ideas about your field of work? And basically would want to know, where did this whole fascination in your life pitch from, and later on, in fact, went ahead to become your career choices? Can you just throw some light on that bit?
So for that, I have to go a little bit back in time, maybe 15 years back. So that time, 15 years back, I was an maybe 12th standard student, something like that. So I was good at mathematics, but then, the trend is to go for engineering. Okay, I also went for engineering. So that time, as you told, I joined College of Engineering, Trivandrum. So in that time, this order of preference was electronics, applied electronics and instrumentation, and then computer science in that particular college where I studied. So I didn't get electronics and communication. So naturally, I went for applied electronics and instrumentation. So that was one starting point where I was getting introduced to instrumentation. So it was not like by my choice, it was maybe some kind of an accidental or something like you can call it. Later, I found this area to be interesting. But I should say that during my 4 years of undergraduate curriculum, I was more interested in some other subjects than instrumentation, to be very frank. I was interested in subjects like control systems or digital signal processing, etc., because they were having more relationship with with mathematics. As you know, instrumentation is a subject which is not that much related with mathematics. But actually, always instrumentation has attracted me than me getting attracted to instrumentation. So the thing is that that time we had something known as mini project and main project. So I had done these mini projects and main projects on the field of instrumentation, but they had some control system components as well. But basically that was because the availability of topic was like that, etc. But then I should say that the real so-called fascination for instrumentation developed when I joined IIT Madras. I had applied maybe for control system. Control system was my first choice and instrumentation was my second. But after getting in there, I had a discussion with my then future guide. Then he showed me some works which he had done, maybe in instrumentation, electronics, etc. So that point was where I was really kind of fascinated towards this electronics and instrumentation. And from that point, maybe that was in 2010, around July. So from that point till now, I am working on different areas of instrumentation.
Okay. So, sir, like now that you tell me that there is this fascination for like underlying fascination for mathematics that you always carried, and but you could not directly pursue it. So, would you say that maybe in every project that you take up, in every research field that you take up one by one, you always look for this underlining essence of mathematics, or where this comes out the most, sort of a thing? Is there?
Yeah, I always have a like as you told, I like mathematics very much, but somewhere in the way I lost. I mean, diverted away from the mainstream mathematics. But I do apply mathematics. See, although my research field is applied electronics and instrumentation, I also do a lot of applied mathematics. So applied mathematics can be simple enough, but I feel the mathematics concepts which is relatively solid for me had helped me a lot to be different from other researchers in instrumentation. So that way it has helped me a lot.
So, sir, just a tiny question here, one more. Like, when you look at basically when you're planning to design a sensor, for example, so there is a plethora of technologies and various fields that you can, like, techniques that you can employ to actually create a sensor, and there are multiple components that can be used. So how do you go about this entire process, like choosing the right kind of component or the technique, and where does the intuition for you lies in all of this?
Yeah, sensor design is a very challenging task. First of all, I feel that a sensor should be designed from the scratch only if there are some issues with the commercially available models, okay, commercially available sensors for that matter. So I feel that if you are having a solid problem where we have to develop a sensor, the first thing is to sit down and make a mechanical drawing of the sensor unit. Okay, how we can maybe integrate the our sensor unit with a available application. Okay, so we have to do some kind of a mechanical modeling plus an electrical modeling, because finally we have to get an electrical signal out. So after that, we have to, okay, basically my flow is something like this. I am an electrical engineer or an electronics engineer. So once the mechanical design of the sensor is ready, I will try to work upon their electrical equivalence. Aerospace people may disagree, but I will try to, as soon as possible I get a mechanical design. I will try to come to my comfort zone, that is electrical. So there comes a little bit mathematics. Okay, whenever we are working with electrical equivalence, we have to bring in some analogies and mathematical stuff. So once that is electrical equivalent is done, or then we will get a fairly good idea about how the sensor will behave, what will be the characteristics, etc. So then we will be able to improve the sensor and maybe improve the mechanical features, etc. So this will be followed by some simulation studies, of course, making hardware prototypes, testing, miniaturization, etc., etc. But the most important thing I feel is the initial design and its conversion to maybe an electrical equivalent.
Yes, sir. Listening to the way you go about with your work and the way you work with a sensor design, it is pretty evident that you have an inert love for this. And as we have gone through your research process and all the publications you have gone through so far, let us start off with one certain thing that has been protruding out very evidently, and it is this very specific word called an angle sensor or an angle transducer. It has started off from the time you have been working on your PhD, and it has been continuing till now as one of your very inherent work. And you have been working on it with a lot of rigorousness and with a lot of love. So, would you like to throw some light on where this interest has sparked in you, where you look at two intersecting lines and then you find it interesting? Could you tell us what and how did you go about with this?
As you know, in 2007, I think if you look at the Nobel Prize in 2007 physics was awarded to Albert Fert and Peter Grunberg for the invention of giant magnetoresistance. Okay, so the giant magnetoresistance technology was very upcoming one, and then new angle sensors based on that particular new technology was just being out in market. So we were trying to use that particular technology towards this industry problem. Then we found out that there is a mathematical problem there. Naturally, I got fascinated. So the problem was something like this: sensor had giving a particular non-linear behavior, inverse cosine behavior, and I had to make a circuit to linearize it. So then I was I should say I had spent about 2.5 weeks to get an idea which can do that particular function. Then it started coming, and then we slowly incremented that work, and finally made it maybe industry ready. So maybe after one year or so, again the industry partner visited us, our labs. Then they told, okay, your works are very good, but then it has a small problem that it will not suit the mechanical constraints posed by our application, by their application. So then in the second part of my PhD problem, I developed some sensors and electronics for that, particularly for the through shaft angle sensing problem. But then first part was not fully completed. So once I was out of my PhD, so I was in Kharagpur, IIT Kharagpur. That time one PhD student had joined me. So then I continued the first part of that PhD work, and that is seen across in the form of many publications which has come out recently. So that student has also passed out, finished his PhD very recently, and so that way we had got a number of publications. But we were the point is that that is a very, I should say, very interesting area which has a number of applications, even in robotics or automotive sector, aerospace sector, etc. So so I should say somewhere now it has got saturated. So that is why I'm going to kind of moving on to new fields as well. Okay. So this kind of repeated nature of angle sensors or angle transducers, whatever you call it, was seen partly due to an industry requirement and partly due to maybe my interest in mathematics, that problem of inverse cosine, maybe I should say.
Yeah. So the repetitive nature was very evident in your publications, and as we went through all your publications, we've seen that you've tried to employ multiple techniques in understanding how you can work with an angle transducer. So could you elaborate the certain process that you went through, and what was your reasoning behind choosing multiple techniques and understanding why that working was going on?
So as far as one of the first part of my work, which I will call that inverse cosine based work, was concerned, it was more about improving the circuit. Okay, initially the circuit developed was sensing rotational angle until 180 degree. So then we wanted to sense across 360 degree. Then there was an improvement. Further, there were a lot of challenges. There were a lot of issues in the first schemes, which was continually getting overcome with the subsequent schemes. So that was one part. Now, in the second part, I should say, it was more of the so-called the sensor design, which you people are referring to. So there, the job was more challenging. I was it was not mathematics. Okay, it was a lot. The selection of the right contours, right shapes, etc. So I'm still continuing that part of the work with some help of some aerospace colleagues. But there we had to come up with some interesting structures like spiral shaped structures, etc. so that we can sense the angle. So it was I should say both parts was very intuitive for me. One was area which I loved a lot of much, that is mathematical modeling and circuit development. Other one was more like made me ready for the industry, I should say.
Okay, yes. So even this was one thing that we found out, that you have a patent in this field, and I would like to quote the patent. It is a combined reluctance Hall effect angle-based sensor, which was acquired in 2013. So could you tell us what this is and how it is valuated for you in your current field, and how do you think this has pushed you in your field?
So this patent was filed maybe in the final years of my PhD program before I left from IIT Madras. So basically, this was a kind of a prototype that we made for that one industry partner. Patent is very, I should say, it is a very technically sound one, and it is one of a kind design which helps in through shaft angle sensing. So it has multiple applications, and it can give like a range of about 360 degree, etc. So that patent was, of course, very much helpful for me for maybe more for my career, and maybe the further research aspirations, etc.
Yes, sir. So, as we have seen that, how do I put it? You have been doing extensive research on a certain topic, and you have been working along a lot of people, a lot of students as a researcher. So, could you talk about your current work apart from angle sensors and how you have been involved in it? Could you elaborate what is the process that goes behind the doors of a lab, which is not, visible to a student as just a graduate student? So, could you talk about that for some time?
So actually, have a lot of fun working with undergraduate students, I should say that. So if you go to my Google Scholar and count the number of papers of undergraduate students, right, there I think more than that I publish with maybe PhD students. Say like I am working in a different number of areas. Most of these areas was started with the help of undergraduate students, and some of them have given me a lot of maturity of the products or the circuits or sensors as well. So presently I work apart from the angle sensor work, I do work on a particular very challenging topic like low current measurement. So this maybe you may not see in my publications because it's somewhat related with ISRO projects. So here we have to measure very ultra low currents, which can be as low as 1 picoampere or even lesser than that. So this actually we had maybe reached until 10 picoampere levels as of now, and actually one of this electronics was like a part of the payload which IAST sent in PSLV C47 mission. So it actually so basically this payload was used for ionospheric studies. So this is one of the ISRO activities that we do in our instrumentation and measurement lab. So apart from that, I work extensively for making interfaces, digital interfaces for resistive and capacitive sensors. Apart from these works, I also work on a new area of chaotic electronic circuit. Okay, this works were again started by one of your senior students, undergraduate students. So the basic idea is to use chaos in electronics. So this chaotic nature is usually not well appreciated in other fields of maybe engineering like aerospace or fluid mechanics. But we try to exploit the phenomena of this chaos so that we can extract more information about a sensor or a sensing variable, or to develop an analog to digital converter, etc., etc. So that is another work which we are doing. So this is again a mathematically intensive work, which I believe will bring me back to my roots of mathematics. Okay. So I mean, over time, I like to slowly move to different areas where mathematics and instrumentation are closely coupled together. So I also do some other industry relevant projects like non-destructive testing using magnetic sensors. We suppose we have to measure or estimate the cracks or fatigue in aeroplane foils or welding structures, etc. So we had developed some magnetic sensing arrangements which help to do such non-destructive testing.
Yeah, of course. Yeah, so we went through your research and it was pretty elaborate to actually point out at one thing. But I think through the conversation, there is one thing that we can say is, like you said, instead of you looking for instrumentation looks for you and you look for mathematics. I think that's how it all goes.
Yeah.
Yeah, I guess that's
Yeah,
the
yeah.
perfect way to put it across. Right?
Exactly.
Yeah.
So, sir, like you
Yeah.
said that you worked in the industry as well. We went through your profile and we also learned that earlier you worked in industry and then you moved on to academia. Can you tell us what was the primary reason behind this change? Why you chose to do this?
Yeah. It's like I was born in Trivandrum, I should say. I studied in Trivandrum and I did my BTech in College of Engineering in Trivandrum. So I wanted to have a more external exposure, okay, before doing any further degrees or educational degrees. So then I got a campus placement in one of the multinational companies. Then I joined there. So the work was more on networking. Networking means network management systems, which is again another part of electronics engineering. So the basic work is something like writing software code for an NMS, network management systems. So the work was very challenging, I should say. I mean, it was like very time-bound work. There was a lot of development activity going on, and maintenance activities also was there. So it was something like that particular tenure of 2 years from 2008 to 2010, where I worked in industry, actually made me like face the world, I should say. In the sense we had to struggle a lot because the workload was too high. So I mean, there was a rapid shift from a kind of a college easy-going boy to maybe like a professional. So I should say, I mean, we had to work maybe every 16 hours per day for maybe long 1 or 2 years like that. So it was very like kind of struggle. Like it was but it was a fruitful struggle, I should say. I also liked the work, and fortunately, I was in a very good group which does a lot of work. So I should say the work was very challenging, but then I was also not feeling that this is not my area. When during the 2 years, especially after the first year, we will get. I mean, I got used to that field. I know what way this field is going to develop, etc. The first year was quite challenging, I should say. As you know, we will learn the most in the first year. After first year, your learning curve will get maybe declined. So after first year, I was feeling something like this is not my area. I should move to electronics or control systems or like some kind of applied electronics area. So then that is where I started preparing for master examinations, etc. The point is that I got a lot of insight into how to work. Okay, although that field was not my area of interest, like how to approach a problem. Like you asked now some time back, how did you design a sensor? Okay, I mean, I feel that designing a sensor would be the same as maybe designing even a like car or aeroplane or any other, or even a software. We have to go step by step, right? Meaning some of these activities, especially in sensor instrumentation area, some of these activities are very different from each other. But that industry experience was quite invaluable for me because I got to know how to work. Okay, how to approach a problem, how to do it maybe within a limited amount of time, etc. So I should say that period was I always cherish that period. Okay, I mean, I had still I like always whenever I am getting there were some deadlines here and in my wherever in my organization, I always look think back. There I had worked 18, 19 hours per day. So yeah, so we'll get I felt that I got a lot of responsibility from that organization also. I mean, ownership. We have to take ownership of a component, etc. But I should say that it is different from the academia experience, etc. Because in academia, we tend to focus more on a particular problem and solve that problem. Okay, so it is we have to put a lot of thought process, and but in a industry it is not, maybe the other way around. We have to meet the customer or the product deadlines, etc.
Yeah, that is true. So, sir, I understand that industry was pretty, we can say, challenging and hectic for you as well. But I also see that through this conversation and through your work that you have had a love for challenges. I mean, wherever you see that it gets more challenging, you choose to take it up rather than moving on to the next thing. So, can you tell us, like, uh, being industry being challenging, but you decided to move on to academia, where you could have also been actively part of the research and not been a professor. So, can you tell us what motivated to you to become a professor?
I see. I was always interested in teaching. Okay, this is something which came to me maybe sometime in engineer, maybe UG first year, something like that. I mean, maybe some engineering chemistry, some professor asked me to teach something. Then I taught, I think the topic was mass spectroscopy, if I'm not wrong. So I taught in front of a class of 60 people. So people were telling, you are teaching well. Okay, so then I thought, okay, this is good. Then maybe after that, I had taken many lectures. I mean, maybe 6 or 7 lectures throughout my 4 year this curriculum. Then people are telling, yeah, you are taking it well, something like that. They were telling. But it had some issues. My writing on the board was not very good, as you people will know. I mean, handwriting is not that clean, etc. But still, people are telling the style is good. Okay. Then I was further encouraged to take teaching. I should say, I had taken many classes as a teaching assistant in IIT Madras. So again, that also motivated me. And then when I was thinking back, I think that I used to when I was a student like many of you, I used to not only listen to the lectures, okay, listen technical content. I think I used to see their way of teaching also. So now, now when I think back, some of the styles or teaching methodologies which I am adopting are very closely borrowed from my previous professors or something like that. I like teaching, yeah, that is it. So I wanted to teach, but then I felt that research will help me to teach better. So research will help me to teach better because they both are very tightly coupled together. So like if I do research on a particular field, I'll be able to teach better in that field. So that is why I felt taking up maybe a role of a faculty in a reputed college will be one of the best options for me. Anyway, I had some years of industry experience. So that is why faculty position was maybe better for me, I thought.
Yeah, yes, as we have been students of you, we know how you portray your love for teaching with the way you prepare yourself, the way you come up to the class, and the way you teach is very intriguing for us, and it keeps the student's mind glued to the blackboard or the way you're teaching. So, could you tell us about how you go about as a professor that day? How do you prepare yourself? Could you explain a little bit about your teaching methodology and why do you go about in this way?
Okay, I mean, I feel that to teach a particular concept or a topic, we should have a firm grip on that subject or topic, and we should think like the audience who is a student. Okay, so whenever I teach something, whatever be it, I used to think whether I will understand at your age or at the student's age, when I was at the student's age. So and more importantly, to be very frank, when we study something, we generally take some assumptions. But one of the main agenda or main points for me when I started my teaching career was to remove those assumptions. Okay, I didn't want to assume anything. I want to remove those assumptions. This was especially challenging for me during my initial classes. Okay, because these assumptions, even in textbooks, etc., they assume that or consider that this is the fact. But to remove that those assumptions, it was very difficult for me. So there were times, especially when at IIT Kharagpur, my previous tenure, that I had to spend more than 1.5 weeks to prepare for one lecture hour. Okay, so we that time, if you look back more closely into my research profile, my 2 years at IIT Kharagpur from 2014 to 2016 do not have much publications, research publications. That 2 years was kind of the years where I focused very much on teaching. Okay, and so my teaching methodology, I should say, developed at IIT Kharagpur, to be very frank. So I used to overhear the classes of very reputed professors who had more than 30-40 years of experience. I used to sit in their classes and I used to listen to them. And apart from that, I used to, I also borrowed some of the styles of my previous teachers. Okay, if starting from maybe even school level, mathematics teachers, engineering, my teachers, my guide, supervisor, etc. So my teaching methodology is kind of a combination of all these things. Whatever I feel optimal, I have taken from it. And I also feel that we should have a sufficient modulation while we teach. We have to stress on some points and stress less on other points, etc. So there are many teaching methods, which I had go through my experience developed. But it's more like we should have the right preparation, the right kind of preparation, so that we can face the students and we can face them with confidence.
So the amount of effort you put into this, you have some expectations from yourself, the way you come across, the way you teach. So do you similarly have any expectations from students?
Till date, I have taught classes of 6 people. I've taught classes of 20 people in your engineering physics branch. I've taught classes of 50, 55, 60 avionics. And back in Kharagpur, I used to teach classes of 180, a huge classroom, theater-like classrooms, etc. Whatever be the class strength, we should, I feel a teacher should communicate well enough with the students, whether it is a backbencher or the first bencher. We should treat everyone equally. Everyone gets equal emphasis and equal maybe take-home messages from their given class.
Further, I'd like to ask if there was any other research direction that you are not currently pursuing, or you always wished you had pursued but could not, probably because of time constraint, or maybe you went into another line. So can you tell us about some of such research direction which you hoped you had pursued?
See, as you mentioned now, I previously worked on a network management company, which is basically a networking software company. So now, when you asked this, I was thinking, what area should I work new? Then I was thinking, what about sensor networks? I work on sensors and I can adapt from my previous, maybe 12 years back, those concepts. So, concepts will come as and when we talk. Okay, or as in one, even if even when I walk on a corridor, some ideas will materialize. It depends on what to pursue and what not, right?
Okay, although this is difficult to imagine, but I would really like to ask you, had the field of academia not existed, or taking up research, you would have not taken up research, what else possible career path would you have chosen? I mean, but to be honest, it's very difficult to imagine you in any other setting, given that how elaborate you are here. But we'd really like to know.
See, see, I should say that this dream of being a teacher came in somewhere around 2006. Okay, but if you ask me, maybe early 90s or something, when I was a kid, what was my dream? Then I used to tell all the people whom I know then that I want to become a scientist at Vikram Sarabhai Space Center. Okay, I mean, maybe you can ask why. Maybe it's because my father had worked there for about 37 years. Okay, so we have, but then we that was my childhood dream. Okay, but but then after some time our dreams get changed, right, modified. By maybe 2006 or so, I was always passionate about teaching.
So we would like to conclude the session here. So before we close the session, do you have anything else to say or anything that you want to convey to the general crowd?
This is a very good opportunity for researchers and faculty like me to kind of expose maybe the other side. Okay? So I really thank you for inviting me to this lecture. So maybe after 10 years or so, you can maybe invite me once again. Then you will see whether something has got changed. Also.
This was Zeroing In with Dr. Anoop C.S. We extend our sincere gratitude to Dr. Anoop for sharing stories about his incredible journey in the field of instrumentation and sensor development, along with British Suntake for collaborating on this episode. On behalf of the Zeroing In Season 2 team, which includes Murala Aman, Kandan Narayani, Kriti Raj, Arun S., Sean Ethan Chaudhary Kanchal, and I am Shreya Mishra. Thank you for listening to this episode. Zeroing In is a non-profit initiative by the Alumni Association of the Indian Institute of Space Science and Technology, Thiruvananthapuram. If you have any suggestions, you can write to us on zeroinginpodcast@gmail.com or contact and follow us on our Instagram and Facebook handle @zeroinginpodcast.